Thank you. I'm Brian Yanites from Indiana University, and I'll be synthesizing the in-person and online discussions in the landscapes and seascapes. I advance like this. All right, so much like acquiring an amphibious RV would transform your family vacations, there was lots of discussion about how offshore activities could be transformative in the landscapes and seascapes. And it was noted that this would definitely have to leverage, just because of the general cost, would have to leverage other activities, both in SZ4D, and it was also noted that there's an international sort of initiative, Seabed 2030. It was, sort of echoed that the high resolution bathymetry allows one to observe fault ruptures, address questions related to partitioning of strain and coseismic rupture, but that we'll need to prioritize where we get this particularly high resolution 1 meter type postings. And then it was also noted that repeat bathymetric measurements could be particularly transformative in pre and post events. There's also discussion of leveraging the geologic record. This is especially important to addressing LNS questions. The sedimentary record in particular offers one way to integrate across the two driving questions. Remember, there's questions about cascading sediment from landslides through the fluvial systems, as well as the energy budget of the upper plate and strain accumulation. And the geologic record offers a way to integrate across those questions in a transformative way. And this would include mapping surface geology, constraining history, monitoring processes, potential to be transformative. But there was also discussion that we really need to know where in order to really articulate the transformativeness, because processes can change, and especially in the landscapes and sort of seascapes realm, change in space and time quite dramatically in different locations. It was noted that the landscapes and seascapes groups, and this has come up at many meetings, often is viewed as the glue to the subduction zone system. There's particular highlights of questions about volcanic eruptions, resurfacing, where some places that resurfacing from these volcanic eruptions can be very different, and then the propagation of that sediment through the landscapes. Material properties and fluids influence landslide initiation and runout, and this is rheology and fluids was one of those sort of cross-cutting themes, and so that was a particular sort of thing to highlight in the landscape and seascape discussion. There was lots of discussion that we still need to work on defining boundaries, geographic boundaries for one, and there's the maps downstairs that we're urging you all to participate in. But also there's questions across strike, right? We've been talking about the arc to the trench, and both in person and online was like, what about the back arc? And so what are we doing with that? And where are we going to go there and instrument? There's questions also, what is, for the energy budget question, what is the representative volume? So I think to sort of summarize from 20,000 feet, like my big takeaway is it's time for the nuts and bolts, right? We got to put dots on maps, and we need to start doing that in order to really articulate our opportunities. And one particular example that was brought up is we can do this in we're going to be in Cascadia. We can do this. We know there's landslides. We know there's gradients and material properties and other things, and we can start doing that, and we very much should. And so that is all my synthesizing that I have for you. I know there's lots of discussion, and this is a very sort of broad overview, so I encourage people in the groups. I don't know if there's a way to do for online. And
so if you're in Zoom land, you can put a comment or a question in the chat and we will read it out. And again, we have a couple microphones here. Don't all rush up at once.
There's a lot of great discussion about sort of these, about, seafloor observations, that if anybody that were making those comments somebody want to talk about, was it the Seabed 2030? That was something that we learned about. Or, okay, Sean's got something he's going to say.
Nobody wants to hear me talk, though. What I was going to say, another component that we had discussed was doing temporally broadband geodesy, spanning the record from like tens of millions of years to probably decades or years. And this is going to be a fundamental component that is relevant to the LNS working group question about the energy budgets, but this also relates to FEC and MDE to be able to address their questions. And I think that that's once we can, as Brian said, put dots on the map, we can better refine that and describe how we're going to try to approach that. But that I think is another fundamental thing to highlight and a big target for LNS.
Yeah, just to follow up on that, what struck me is there's an incredible amount of work that could be done, but we really want to focus that into areas where we can leverage existing data, but in particular, connect with the other programs, the other, I don't even know what you call them, the FEC.
MDE.
And the reason for that is because it helps to focus the questions that you're going to try to solve. And that helps to focus the methods and the places and so on. And what I heard was this very, very broad perspective of let's look at all these different methodologies, onshore, offshore, and try to tie them together. But first, what are the questions that you're trying to answer? I think those questions will be guided by the connections with other parts of the program.
So I actually had a question for the LNS folks. There's clearly a lot of interest in let's start working on putting dots on a map. How do you approach that? There was this great map that was shown yesterday, I think Leaf put together, of landslides in Cascadia. And is that step one is kind of starting to compile those types of maps, maybe other properties, or is that already existing information? Is there like a known data? Is there like a data discovery compilation step that has to happen so that you can start to logically figure out these are places where we might want to target? How do you?
Yeah, I mean, all of that has been sort of compiled and viewed, and I think, I guess this is sort of me giving my sort of opinion on this. Since the beginning, the Landscape and Seascape group has been really focused on generating questions that tie together into the magmatic drivers and the FEC group. And so, right, like I tell people, I'm a geomorphologist. I can work anywhere on the earth, right? The surface of the earth. I have projects in Indiana, right? But what's special about subduction zones is these connections with these other groups. And so I think the compilation, the data's there, like we know where stuff is happening and what is happening. But as I mentioned, processes can change, rates of processes can change. And so what hill slope we might, type of hill slope we might want to instrument to get at might change depending on where we potentially co-locate these arrays and things like that. Does that answer your question?
Well, it sounds, and I'd be interested to hear from other LS folks that, the choice of locations for you is really a process that it involves discussion with other groups. It's not something that you necessarily want to come, here's our list of favorite watersheds. It's more integrated.
Yeah, because that for, at least from my perspective, that's the transformative science, is crossing these disciplinary boundaries and thinking about it as a system. And so it very, very much requires a whole SZ4D discussion on that.
I'll continue to be the annoying sedimentologist in the room and just say that if we do want to look at the sedimentary record, we need to look somewhere that has a nice preserved thick sedimentary record that is either well exposed or something that we're willing to core. And so one of those two criteria has to be met, and we need to decide how deep in time we want to go to decide what sedimentary record we're trying to target.
And I'll just note that's actually really important to the MDE group as well. We need very good preservation of volcanic deposits. So this is a nice starting to refine some cross criteria for site selection. Other comments from LS discussion participants, signal boost, add detail, questions for the LS group about their discussions? All right, Sean's back.
So, yeah, I'm back again. Sorry. One thing that we didn't discuss that I think deserves attention is the modeling components of LNS. And so we're looking to do things to better understand landslide initiation and runout, which includes the development of new multi-phase physics models of this to be able to understand that process. But we also need to be able to develop these efficient algorithms to evolve landscapes and seascapes on really, really long timescales, with the end goal, I think, of making the numerical computations efficient enough that we can do Bayesian style inversions of data sets to unwind the landscape history through time. And I think both of those goals are not easy things to address, but this is something with the modeling collaboratory that we might be able to make significant progress on. So I just wanted to make a plug for the modeling component that we didn't discuss in our breakout.
Hey, so find some LS folks at the maps and let's start talking about how to put dots. Thanks, Brian. And so now, oh, thank you, Brian. All right, so next we're going to hear a synthesis of the FEC breakout discussions, and Samer Naif is going to present these, followed by, again, audience discussion.
Good morning, everyone. So I had to synthesize three working groups on FEC and 2 online as well, which means that a lot of what you'll see in my laundry list is either things that resonated with me, or I tried to pick up on comments that were in multiple groups separately, or things that were really repeated multiple times in any one group, which means there'll probably be stuff left out. So I encourage people to speak up once I get through these slides. So I tried to break it up into the questions for how I organize things. And so I broke up the first question actually into 2 parts. And the one thing that really stood out to me was only, I think, 1 comment, but I felt like it really got at the whole SZ4D effort. Is what makes this unique is that we're going to look at subduction zones through the lens of geohazards, but it's going to be framed by collective impacts, which is, for me, I think, and for many of you, a really powerful, exciting way to look at things. Another thing that definitely came up in multiple groups is that it's going to be really exciting to illuminate what's going on in the near trench environment in terms of the plate locking state and shallow processes, which means that a seafloor geodesy is obviously going to be critical for this. And then also the fact that we're going to be able to compare different segments and different source parameters, for example, from various types of earthquakes. And so the fact that different segments behave differently will help us try to get at what their underlying controls are and mechanics. And then also it's going to be really important to integrate the geophysical observations with what's happening from what we're learning from onshore analogs and exhumed terrains, and then also in the laboratory experiments. But really all of this will be integrated through modeling. And so like what Brian said earlier, the modeling aspect of this effort is pretty critical to every component of what we talked about. And then for sure, the 4D in SZ4D, right? The fact that we're going to start to get at the time in how these processes behave. And some examples of what came up in discussions, at least in our group, and this was actually mentioned in another group as well, that we'll be able to do repeat surveys. For example, when it comes to geophysical imaging, we can do a before and after an earthquake rupture to see structurally what might have changed, as well as in the time series itself, to look for repeating patterns, behaviors, and maybe even get at, and decadal might not be long enough, but could start to get at whether some of these asperities, for example, are actually fixed asperities or are they migrating in space and time. And then, of course, the decadal observations are going to be key to start to try and identify if there are precursory phenomena and transient phenomena. This is the second part of the first question of what kind of activities should we potentially be given high priority. I've focused in really on only the modeling, experiment, and analog, and less of, for example, what kind of geophysics data for this list here. And so it did come up that we're going to need to pay attention to compare different types of exhumed, at least 2 types of exhumed terrains, for example, and look at systematic collaborative studies to leverage different methods to tease apart what the differences in these separate locations, what they have in common and what distinguishes them. Also getting at experiments to investigate time-dependent behaviors, which is a difficult thing for any one laboratory group to do. And so this really does take a community effort because of the challenge of doing these types of experiments. And then I think this is really something I personally stress, but seemed to resonate with the group, at least the group I was in, was that if we really want to do integration, which is one distinctive aspect of SZ4D, then we actually kind of need these tools and modeling codes upfront in order to actually enable researchers to do it instead of trying to do it after the fact, which is kind of how it was like in, for example, in GeoPrisms. And existing data sets also came up many times. So we do need to leverage and go back and mine those data and try to get more out of them. Local Chilean expertise is going to be critical. And so that collaboration will be really important to start picking up speed. And then this will come up again in another slide, and I'll try to speak faster to give people time to talk, is that we need really established protocols, including, you'll see in another slide, for example, data products that will need to have uniformity instead of they're specific to any one group style of work. And then paleoseismicity came up a couple of points where that could actually be a key way to link, for example, Chile with the pretty phenomenal paleoseismic record from Cascadia, and then of course geodynamic models. And so for adaptive notional plans, we really need to think more carefully about what the target of these densified arrays are, because we do care about along strike variability and where will we go. You know, we have to know things about the seismic gaps, where slip might be happening, boundaries, and all that good stuff. And we really need to work with in-country partners to identify our shared priorities, and including geographic areas that may be favored over others. So I'll let you read some of these other ones just to speed things along. Chile is really large, right? And so we do have work cut out for us to identify which parts of Chile to hone in on. And I think the last point here is also really critical, that we need to start digging in our heels and evaluating the instrumentation and the instrument objectives to make sure that we can actually record what we hope to record. And this was basically my last slide of things I didn't know quite how to categorize, but came up many times in various notes. So there's always squirrels in the room, right, when we're doing breakouts. So there's the upper plate matters. For example, Cascadia, especially splay faults might be really where the hazards are coming from. And so we need to not forget in FEC how important the upper plate is. And I think a lot of people would agree with that. And we also want to make sure to continue extending coverage beyond just the trench and arc to really capture the whole system. And DAS came up multiple times as a really important thing that maybe we should pay more attention to, having articulated as part of the notional experiments. And maybe things like CIDR style workshops to get people together. And I'll end with, even though one of the hopes is that we'll hit the jackpot and capture a magnitude 8, well, even if that weren't the case, we're still going to learn a lot of really important fundamental stuff. And so I'll stop there. Hopefully that's enough time for people to talk.
Okay, so we have time for comments, signal boosting. Sammer got it wrong. That's not a squirrel. It should have been on the first slide, not the last one. Yes, please line up at the microphones here and here for comments.
Hi there, Emily Brodsky, UC Santa Cruz. So you highlighted the need to discuss with our Chilean collaborators particularly you had it under the second half in terms of talking about existing infrastructure, but of course, one would want to discuss with our Chilean collaborators the first half as well, the scientific priorities. And I'm wondering if we could add some specificity to that, not to put anybody on the spot, but a number of Chilean scientists made the effort to come here in person, and there are others who are online. And I still don't really have a sense of what the scientific priorities from their point of view would be in the FEC world. So it's not really a question for you, but I don't know if that was captured in the breakouts or if there's somebody who would like to speak to that. Nobody willing to speak on behalf of all Chilean scientists. How strange.
It's a missed opportunity.
Okay, well, I guess I just, oh, so somebody's willing to do it. Okay.
Thank you, Emily, for the question. We were discussing with Marco Moreno, what would be roughly in these 30 seconds, whether he or I should go and try to answer this question, and we had the difficult debate. But there are certain things that we are doing at this moment and perhaps can be reinforced, but there are others that we're not doing at this moment. And regarding the scientific, I think scientific objectives, it would be to understand how does the upper plate behaves close to the trench. That's a major thing that we have no idea. We have no idea. And why it's important? Because the tsunamis that generate these earthquakes are dependent on that. And if we have a better understanding of that area with seafloor geodesy or some other way on how to understand it, would be a great advance for Chile. That's one of the aspects. I'm sure that if you ask somebody else in Chile, it would have a different view. But at least on this 30-second consensus with Marcos is what we would like to bring up. Thanks.
Okay. Yeah, thank you. Yeah, we had some brief discussion about the mega array regarding experimental design. There are some thoughts whether the mega array, we're talking about Chile, right? Mega array in Chile, whether it should be mostly a single array with dense instrumentation covering a big area, or it can consist of several smaller arrays targeting different things. And it seems like the latter may have some advantages. And Chile, being Chile, it's just an ideal place for subduction zone research, just from the megathrust earthquake faulting perspective. And it's such a variety along strike. And if you consider geology, the most striking is there's a lack of erosion sedimentation in the north and tremendous sedimentation in the south, how that provides input to the megathrust. And talking about earthquakes, we know there are places that earthquake just happened, or there are places earthquakes are going to happen. And so we have a variety of things at different stages of earthquake cycle. And also there's ongoing or existing activities in Chile, like yesterday, that was supposed, I think Marcos Moreno is too shy to talk about it. And he has a project ongoing with numerous seismometers on land, but there's not a single OBS to monitor earthquakes. These are the things, if SZ4D can contribute, not only with the SZ4D own networks, but also make some effort to merge with existing efforts. That would be beautiful. Thank you.
Yeah, I will at least comment that that definitely came up in our group and in the notes of many groups, as well as in the 2 years of bi-monthly meetings. And just to add a little additional comment to that is also the question of, do we have the appropriate baseline or background to then start knowing where best to target and different strategies for how to maximize the likelihood of success of getting at the questions. So these are definitely key, very critical questions to get answers to.
Hi, everyone. I wanted to give a comment about what we talked about before, but sorry. Oh, sorry. I'm Valeria Cortez Rivas. I'm a PhD student at Northern Arizona University. And I wanted to make a comment about what I've seen. I don't know if I represent the Chilean community, of course, but I feel that the approach has been through the science view, and all the discussions that have been about how to interact with the Chilean community have a feeling of being in the future. So I feel that the discussions should actually have at its core what is going to be the role in a more practical way. And I know that some Chileans actually wonder that, like, who's going to do what are going to be the benefit of each group, who's going to collect the data, or how publishing is going to be done, or all those points. I think they should be part of these conversations too, because it feels very like, I love it, but it feels like too surreal in some way. So maybe we could start including those kind of things in the planning from now and not seeing it so much in the future. Thank you.
Hey, that's a really important point. Thank you. And I think this is a key point beyond any of the working groups. And we are very fortunate to now have Chilean scientists on, I think, all of our new committees. So hopefully that's a step, but thoughts about how to do this more, how to really push this integration of discussion to the forefront are very important as an outcome of this meeting. And I think we'll have some of that in the discussions later today and tomorrow. Any last comments from FEC?
We did have a question coming in from Sergio Ruiz as part of our online audience. I think this is in response to maybe Kaelin's comment, but he says that in most of Chile, the intermediate depth intraplate seismicity rate is very high. This seismicity is probably connected to the megathrust and perhaps volcanism. So it's important not to forget that piece of the equation as well.
Okay. Oh, one more from Brian, and then let Sam off the hook.
Brian Yanites, Indiana University. I guess so. This question is also sort of a signal boost. What does FEC see as the sort of transformative opportunity for having an integrative cross-disciplinary sort of program in the SZ4D? If anybody wants to sort of highlight that.
I mean, I can give you my personal take. Well, maybe hopefully someone else can get up and say something. But for me, as the one of the minority EM people, I'm super excited to really get at integrating properly with other geophysics, but not just geophysics, but geochemistry and what's happening in terms of surface evolution, how all those things connect. So I feel like we keep saying we like those things and we want to do them, but it's really hard to do them. And so how do you do it? And to me, this is what SZ4D captures that movement. So I think it's shared across many people, but I'd love to hear from others as well.
And yes.
Yeah, maybe I can do a little add-on to that. As Sean brought up earlier, right, that 10 million year geodesy, understanding what's actually happening in the upper plate over very long periods of time is extremely important for us, not just to understand the physics of how we're accommodating strain, but also really understanding the actual hazards that are most prominent to the local population, because it's usually the smaller continental transform and other earthquakes that are usually more damaging to populations. So.
Hey, Harold, final point.
Yeah, hi, Harold Tobin, University of Washington. We've just heard this emphasis on, okay, upper plate stuff matters a lot. What's happening relatively shallow. And we also heard so much cool stuff from the LNS group. And I'm just wondering a little bit about whether we're really fully taking advantage of the Seascapes half of the LNS equation, right? Seems to me that seafloor geomorphology is the frontier for all of this, and it ties the FEC effort and the LNS effort together in a way that could be really important. And I may just be ignorant, but it seems like there's not really a critical mass community yet for that. So what can we do between the two working group sides to really foster the effort in seafloor geomorphology and all the things we can do to address these exact questions we're talking about? So it's just sort of a broad question or exhortation to do it, I guess, but.
Okay, I think that's a great point to end this on. That's actually going to be the topic of our next breakout. So excellent point to end on. Thank you, Samer. And finally, we are going to hear a synthesis of MDE breakout discussions from Pete Berry.
All right. Is there a pointer up here? Oh, it's just here. Got it. Cool. Yeah, thanks. So, yeah, I'm going to be talking about the breakouts from yesterday. So we had 2 in-person magmatic drivers of eruption breakouts, and then there was one online. So, yeah, I just want to go through some of the points and just really start with, going through pages and pages of notes and discussions, what people were really most excited about. We were tasked with looking at these notional experiments and thinking about, modeling and observations and what would be most exciting or most important. And first and foremost, we've heard this time and again throughout this meeting, the interdisciplinary nature of this research and this program is what's getting people most excited. And I think the implementation of that, the discussion we're just having just now, like how do we actually implement that, is kind of the burning question. How do we? I think these meetings are wonderful for bringing folks together to actually talk about interdisciplinary science and start those projects. But we should continue to think about that as we move forward. And kind of to that same point, a community effort will enable funding of research that is probably otherwise unfundable. It requires, so much data, so much modeling, so much different expertise from different fields. So SZ4D is going to really hopefully provide an opportunity for that to happen. Just a few other things that, some of these, creating tools that are going to plug into modeling and observation efforts. And geobarometers are an example of that was given in that working group of these kind of tools and observations that could plug into some of the other models. We noted that we need to strike a balance between what's compelling. I think this was a note from NSF from that we need to really strike this balance between what's compelling and what's development focused. And then, yeah, there's sort of a laundry list here of what people are really excited about. And this one is actually not from me. I was not in the room, but gas and isotope data are really exciting. That's, so people are excited about those data, those observations that we can make in and around volcanic systems, looking at gases that are, actively degassing, measuring isotopes, what we can learn about the hydrothermal processes. So from a MD&E perspective, a few people highlighted this as not really being a central focus, but potentially very, very important to understand the hydrothermal processes. And of course, magmatic fluxes and the drivers of magma. There is a need to potentially convert geochemistry and to geophysical parameters. Putting hazard into context of petrology is a very exciting avenue. And I think, Brian highlighted this, that, the whole framework of SZ4D is really, within the framework of hazards, but addressing really fundamental science questions that are exciting. And then there's a few other things that people are excited about. The field component, actually going out and collecting samples, doing field geochemistry, gas geochemistry, volatile studies, solubility models from experimental side. And then people really emphasized the importance of volatiles in these magmatic systems, really understanding, not only the models and observations, they're super important for the hydrothermal systems, and the budgets are poorly constrained. So there's a lot of things that people are excited about. And I think the consensus was that, more focused workshops in the future will really help us continue to come together and refine these questions. Okay. So getting into like a little bit more of the specifics about what we talked about, there was quite a bit of discussion about the arrays. So if you remember yesterday, I kind of gave an overview of the various arrays that the magmatic drivers of eruption group is interested in deploying. There's a very dense array, this imaging array, and there's a sensor array, which would potentially be deployed at 30 to 50 volcanoes. So there was quite a bit of discussion about what these deployments might look like, and one of the questions that came up in almost every group was, how do we decide the specific volcanoes? And I think that's sort of the phase that we're entering into now. We've spent, 2 or 3 years now thinking about, regionally where we'd want to go and what these instrumentation arrays might look like, but really, kind of a takeaway point. And it's highlighted here, like a goal for the current magmatic drivers of eruption working group is to, pin down and, as someone said earlier, Brian and Diana said, put those dots on a map and actually choose the actual volcanoes. And so in one of the rooms, I was bouncing between rooms because I had to give this overview today, but one of the questions was posed to the Chileans in the room, okay, pick one volcano, where would we go? And so Villarrica was highlighted as a volcano that's currently in yellow alert. People live in the vicinity of Villarrica, so it's a potentially great target for a volcano. But that's just one, and we need to focus on maybe as many as 30 or 50. So there was also quite a bit of discussion about are there other volcanoes, are there analog volcanoes that would be good for broader comparison? Again, like focusing in on the specifics was really a common theme. And there's lots of discovery space in Chile. There's lots of opportunity to understand, there's a lot of discovery space in Chile, lots of opportunities to get a basic understanding of active or potentially volcanic systems that are not well studied. And then this was from the online group. They were really focusing on, you need to focus on both active volcanoes and those that are, going through this entire cycle. So, capturing the sort of life cycle of a volcano is important. And then also focusing on the nature of the crust. So then there's actually a little bit more. So in the other groups, they were also very focused on the array deployments and what these might look like. And if we want to, putting the dots on the maps and thinking about pilot studies. This was something that came up in almost every group, was the need at this point to have pilot studies, to do reconnaissance deployments of these arrays. And one of the suggestions was that this kind of rapid response model might be a potential way to do pilot studies or pilot deployments. They noted that there's many places in Chile that are actively degassing, and we could acquire high resolution gas and petrology data. And this initial deployment was suggested it could be a limited package, and we could assess things like ascent rate and so on. One of the questions that came up was about the really dense arrays that we've proposed is, why do they have to be close to each other? This came up in one of the working groups. I think Terry's, emphatically said, I wasn't actually in the room, but I read the notes, said it's all about efficiency, right? You kind of get like a 2-for-1. If you have two volcanoes that are close to each other, you can exploit the fact that they might share a plumbing system or share some similarities. So, this was important open question that was discussed in that working group, I think. yeah, again, they might be, they're likely these big discoveries are probably going to happen sort of in these interstitial areas between volcano pairs. So, you know, if you remember, we want to have these very dense arrays in, you know, looking at volcano pairs and in all of the arcs that we want to target. Yep, and then it's kind of just a few more open questions that we think we can address about transcrustal systems and the sensitivity of these volcanoes to earthquake perturbations. And then this is, some people didn't like the word cycle, so we had quite a discussion about that in one of the groups. Okay, yeah, this is my last slide. So this is the group that I spent the most time with, and it was interesting that, you know, we in the breakout session that I was in, they focused mostly on the urgent need for better data and sample repositories. So while a lot of people were talking about the arrays and the specifics of the volcanoes, different group went kind of in a different direction. And I think, you know, it's probably the composition of the group determines where it's going to go, but people are really excited about having a physical sample repository. And this discussion has come up time and time again over the last day and a half for me. You know, people are really excited about studying subduction zones holistically and leveraging existing data, but, you know, they want it to be searchable. They want, you know, not only to be able to access existing data, but have a framework to, as we acquire more data, to have it be searchable and accessible and easier to get at. So the need for better databases in general that we can share. And then so we kind of had an extensive discussion in the group about like what this would actually look like, because, you know, providing data in real time is a desire of some people, but what is the cost benefit of a situation like that? And which data types can be shared in real time, and which data types need to be, you know, heavily interpreted and processed before they should be distributed to the community. So these are all really important questions about the availability of data, how accessible and in real time it should be, and what the cost would be. And then many people mention the fact that like we don't need to reinvent the wheel necessarily. We can learn a lot from Arctic research, seagoing research, NASA space research. There's good examples of very well organized and curated you know, data and sample distribution. So learning from the communities that do it slightly better than the on-land geological community might be something we could really benefit from. And then people pushed back a little bit and they said that, you know, basically this is getting better, you know, and this is true in the sense that when we publish a paper, you often have to like deposit those data into EarthChem. When you submit your NSF reports, you have to, all those data need to be made publicly available. So there's a system in place to make the data that we're generating now available. But one of the questions was, you know, dealing with legacy data. Yep, and then just finally, there's discussion about a need for a platform to track these ongoing activities. So just beyond the data and the samples, just the activities, like keeping organized with, you know, all the various communities and folks in this room. And yeah, I think I'll leave it at that, and we have plenty of time for discussion probably.
Thanks. Noah Finnegan, UC Santa Cruz. Not a volcano person, but I have my only experiences working in Chile are working on volcanoes and thinking about kind of long-term geodesy beyond what you guys can measure with GPS and INSAR. And I just wanted to put a plug in for, particularly in the central volcanic belt of Chile, it's really dry, and there's incredible internally drained basins which have have incredible strain markers of, paleo horizontal. There's incredible preservation of ignimbrites, all of which give you, constraints on tilting over long time scales. And this is a way to engage the LNS community in a pretty direct way, to the extent that you're thinking about magma accumulation on the timescales that are longer than what can be measured instrumentally. I think this is a really strong point of connection between, you know, sort of traditional tectonic geomorphology and some of the questions that you guys are interested in, but just on longer timescales.
Christian.
Hi, I'm Cristian Farias from Universidad Católica de Temuco in Chile. I'm missing something out of this, and it's pretty much what happens with the people that is going to work in this in Chile. I know that at least on my group, it came out during the discussion, but I'm really missing it. Like, what's the role that we as Chilean scientists are going to play here? Are we going to be like, you know, people who are just going with you into the field? Are we going to develop new projects that we might be able to, you know, submit it to different agencies? Are we going to create some way of collaboration so we can actually ask for money even to the Chilean government? What do you expect us to do? Because I really don't see it here. Plus, I know that in my group, there was a lot of discussion about structures and structural geology and how magma can actually go up, because that was really important for us in Chile, given that we tend to think about volcanoes from the hazards point of view, because we have so many eruptions. That is not in there. I mean, it's one point, but it's not what we were talking about, at least in my group yesterday. So I just want to point out that I really would like to know exactly what do you expect from us. First of all, I really would love to, you know, engage in the best possible collaboration. Of course, I want. I also want my students to be able to have opportunities, you know, to go from one place to another so we can create better science for the future. But I'm missing that on that. So I just wanted to point that point. Thank you.
Yeah, thanks. Sorry if there was an oversight. I was not in the room when that was discussed, and I did my best job at synthesizing. But I would totally agree with you that I wanted to be a very active collaboration where we're you know, the scientists coming from the States working with the Chileans are active doing field campaigns, but also really engaged in interpretation of data and designing the research questions and writing the papers. I mean, I view it as a full collaboration. So I think others in this room are passionate about that as well, for it to be a really engaged process. So
yeah, and maybe if I can respond as well. I mean, we had a lot of this discussion at the workshop in Chile. I remember there was this discussion about are we focused on more fundamental research, or are we more interested in trying to understand better forecasting? And that there was a really interesting kind of set of perspectives based on proximity to the Chilean volcanoes. So we heard, and it was very compelling to hear that that is a priority criterion. What I think is that as we transition into this discussion of which volcanoes, I think this is a point where we can start to really engage with each other. I mean, we view it as your number 3. This is a full collaboration and trying to meet both our objectives and your objectives as scientists. And we're not there yet, but I hope that we can use the opportunity of talking about how do we get to the set of systems we want to focus on to bridge that gap that exists. I think that will actually be a fun and exciting process. Bill.
Hi, John Browning from Pontificia Universidad Católica in Santiago in Chile. I just want to emphasize a point that we made in our group, at least, how if we're dealing with dense arrays and installing lots of instruments on a volcano, how important it's going to be to involve local communities. And you know, one of the things we talked about there is that these instruments, for the most part, they're going to be being installed in like people's farms, in people's like back gardens and stuff. So it's incredibly important. And I think, so building on Christian's point there, it's going to need local support from local scientists and local communities. So I just want to pick up on that because we mentioned it. I think it's an important point to emphasize.
We've had a number of comments come in on from our virtual audience, and maybe I'll just give voice to a few of those. I think that there was a comment here from Jesse Hutchinson, just emphasizing with regards to data, the importance of having the SC4D community definitely chat with the folks at Ocean Networks Canada and the OOI group for input from those cross-disciplinary organizations. We also had a comment from Jose Luis Palma, emphasizing the importance and inquiring about opportunities for postgraduate students and early career scientists to learn new techniques, things like instrumentation and data processing, and perhaps questions about how those opportunities might be coupled with field deployments and or workshops. Finally, we had an anonymous comment just emphasizing the point that it's going to be important to interface with engineers early on in the process so that we can really realize our ideas in terms of realistic instrumentation, particularly in some of the hazardous environments and the deep water volcanic environments, things like that, where we're going to want to deploy instrumentation as part of this effort. Thank you.
And maybe just in response to Jose Luis, our SZNet proposal that Emily and others described yesterday actually has in there opportunity for student exchange in both directions and student training opportunities, cross international visits, time in each other's labs and so on. So that is something that we are actively seeking funding to do right now. Jade.
Hi, Jade Bowers, Boise State University. First, Christian, I really wanted to thank you for the point that you made. This was a conversation that SC4 grads XCOM had together last night at dinner. And we were really starting to feel like a lot of the conversations were more extractive than they were about what the Chileans could get out of SC4D and the campaigns that we were trying to accomplish. And one of the things that we talked about was how we could try to encourage the development of an SC4 grads for Andes that is more organic than coming in and saying, we're doing this. We think it would be great for you guys as well. And then the second point is we're talking about collecting massive amounts of data in this project. And then you doing huge comparison studies to answer some of our big science questions. I think something that is going to plague MDE is a non-standardized path of looking at our products. And this just comes from seeing a workshop at IAVC talking about the pyroclastic community and kind of standardizing a path in which we determine what data is necessary from the get-go and what it needs to be collected on and specificity of sample size as we go through so that we can start making these big comparison data sets. And one of the things that I saw on our list was these more focused workshops. And I think that maybe that is something that should be a product of one of those workshops, is standardizing what the products we are going to be collecting, and then what data needs to be collected on every single sample and how it should be collected and what the standard is for it.
Yeah, great point. I spent most of the time in the same room as you, and that was basically what we covered. And I totally agree that a dedicated workshop would be very helpful.
Sorry, Jen Wade, NSF. So Christian, I want to acknowledge your comments really from the agency perspective for sure. And Jade, great response to that as well. From a practical perspective, I will say, at NSF, it doesn't matter where you are, like if you're at a US institution, you could bring all kinds of people from Chile and elsewhere to be a part of that project, either as a student or collaboratively, and we can work on that. The other thing that I wanted to say is we have a bunch of international agency to agency agreements. Some of you have benefited from this in this room, actually, from like the US and NERC, the UK funding agency. We have one with Israel. We're working on a few others. And this conversation helps Gail and I and everyone at NSF bring back the possibility to try to establish one with Chile specifically for this purpose. So the way these work is that somebody in the US submits a proposal to NSF and someone in another country submits it to their funding agency. And there's an agreement about if the lead agency agrees to fund that project, both projects get funded. It's a great way to collaborate internationally. And so this conversation over these days is really helping me think about how to sort of try to rally for that. I mean, I'm not committing to anything. It's high above my head, but this is really good, you know, to make the case that something like that could really be mutually beneficial. So.
Thanks. And actually, since I was in, I want to signal boost something I saw, and it wasn't a discussion I was in, but something that really caught my attention here and that gets, I think, to the point is the concept of analog volcanoes. And, you know, Villarrica is obviously a choice, but there has been a lot of discussion about is its twin Pavlov. And I think, you know, we all have in our mind Pavlov in the Aleutians. And I think many volcanologists kind of sort of have in their mind these sort of Besmianus, St. Helens, that sort of like, you know, are these analogs of each other? And it would be really interesting potentially as a way forward to actually look at that in depth, to kind of focus on what we think are twins in different settings. It gives us a controlled experiment, but it also helps us understand what's transferable and to what extent are systems twins and to what extent are they. And this strikes me as actually a really nice bridge towards not just the fundamental science, but also the hazard focus. And so I just wanted to boost that because I saw it and I started thinking a lot. And I would love to have discussion on that. Okay, we're about to finish up. So any last comments on MDE? If not, Donna?
Hi, this isn't a comment on MDE. My name is Donna Shillington from Northern Arizona University, but I wanted to really appreciate the comments from Valeria and Christiane and Jade, and to highlight that one of the specific topics that we hope to talk about in this afternoon's breakout is how to build interdisciplinary, equitable, and mutually beneficial collaborations. And so I hope that we can take the ideas that they've raised that have been so important and use those as a starting place for some discussions when we have our breakouts this afternoon.
All right, so let's give a round of applause to our synthesizers.